Hi everyone, welcome back to Botronix Labs. In this module, we're focusing on something essential before we ever build a full robot: how to power up your Raspberry Pi Pico and control a 360-degree continuous rotation servo motor using MicroPython. We'll walk you through how to wire up a 7.4V battery to safely power the Pico, explain how PWM works with continuous rotation servos, and write code to make the motor spin forward and backward. This is a key foundational skill for anyone starting out with robotics and embedded systems. Let's dive in. Here's what you'll need for today's lesson: a 7.4V Li-ion battery pack, like 2X18650 in series, a Raspberry Pi Pico or Pico W, one 360-degree continuous rotation servo motor, I'm using the FS90R, some jumper wires and a breadboard, sliding power switch for safe on-off control of battery, and optionally a multimeter to check your voltage. We'll power everything directly from the battery. No voltage booster is needed in this module. Let's understand how the Pico is powered. The Pico has a pin called VSYS, which takes in any voltage between 1.8V and 5.5V. It feeds into a built-in regulator that converts it to 3.3V for the Pico's logic. Now let's talk about the motor itself. Unlike a traditional 0 to 180 degrees servo, a 360 degrees continuous rotation servo motor behaves more like a DC motor. It just keeps spinning. The servo expects a 50 Hz PWM signal, 20 milliseconds period. The pulse width, high time of each PWM cycle, tells it what to do. 1.5 milliseconds pulse, stop/no movement. Less than 1.5 milliseconds pulse, 1.3 ms, spin in one direction, counterclockwise. Greater than 1.5 milliseconds pulse, 1.7 ms, spin in the other direction, clockwise. Let's wire it all up now. Connect the battery's positive terminal to the Pico's VBUS pin. Connect battery GND to GND on the Pico. The servo's VCC goes to the same battery positive. The servo's GND is also connected to common ground. Finally, the signal wire from the servo goes to GP1 on the Pico. That's it, one shared power rail and one PWM control pin. Now that our power supply is connected and the servo is wired to GPIO pin 1, let's write a simple MicroPython program to test the servo motor. Open up Thani IDE on your computer and make sure your Raspberry Pi Pico is plugged in via USB. Copy and paste the demo code in the editor, go to the top menu, click on File, then Save As. When prompted, choose Raspberry Pi Pico and save the file as main.py. This is important because the Pico will automatically run any file named main.py on startup. That means your servo motor demo will begin right away anytime the board is powered up, whether it's from USB or a battery pack. Now go ahead and save your file. Then unplug the USB cable and connect your battery pack. If everything is set up correctly, your servo motor should start running in the pattern we just programmed. So let's recap what we've done. We used a battery to power both our Pico and servo motor. We learned how continuous rotation servos respond to PWM signals. We used GP1 on the Pico to control the motor. And we wrote MicroPython code to move the motor forward and backward. This is a great foundational skill for building mobile robots. Thanks for watching. In the next module, we'll use everything we've learned so far to start building a mini robot car. If you enjoyed this lesson, don't forget to like and subscribe to our channel and share your projects with us at Botronix Labs. See you in Module 5.